After learning about the isomerism and the discussion about the different molecules, let us move on to chemical isomerism. Isomers which arises due to fixed position of the atoms or groups bonded to carbon atom are called chemical isomers. You can expect the chemical isomers only when the position of the atoms or groups are going to be fixed, which are bonded to one particular carbon atom. The position of the atoms or groups are going to be fixed only when we are not able to rotate the carbon atom. I mean to say, chemical isomerism always arises due to restricted rotation of carbon atom. So, any molecule to exhibit chemical isomerism, the primary and necessary condition is we have to restrict the rotation of carbon atom. The free rotation of the carbon atom can be restricted either by having a carbon-carbon double bond or by having a cyclic structure. This is the first condition to exhibit chemical isomerism. The restricted rotation of carbon atom to fix the position of the atoms or groups which are bonded to one particular carbon atom, and the rotation of the carbon atom can be restricted either by having a carbon-carbon double bond or having a cyclic structure. And the second condition is the atoms and groups which are bonded to such a restricted carbon atom, and such two atoms must be different. So, chemical isomerism exhibit ಮಾಡಬೇಕಂದ್ರೆ ಒಂದು ಕಾರ್ಬನ್ ಫ್ರೀ ಆಗಿ rotate ಆಗಬಾರದು, rotation ಅನ್ನು ಸ್ಟಾಪ್ ಮಾಡಬೇಕು. So the rotation of the free rotation of the carbon atom can be restricted either by having a carbon-carbon double bond or by having a cyclic structure. That is the first condition. The second condition is the atoms or groups which are bonded to the carbon atom which cannot rotate or restricted carbon atom must be different. Any molecule which satisfies these two conditions that exhibits chemical isomerism. So compounds with same molecular formula and same structural formula and differ in the arrangement of atoms or groups around the restricted carbon atom are called chemical isomers, and the phenomenon is called chemical isomerism. Chemical isomers are again classified into two types: cis isomer and trans isomer. Hence, chemical isomerism is also called cis-trans isomerism. An isomer which is having the identical groups towards the same side of a carbon-carbon double bond is called cis isomer. If the identical atoms and groups are present in the opposite direction, then it is called as a trans isomer. This is cis 1,2 dichloroethane. This one is trans 1,2 dichloroethane. So coming to the other example, so this is the one more example. This is cis butadiene 1,4 dioic acid. This is cis butadiene 1,4 dioic acid. This is trans butadiene 1,4 dioic acid. Coming to the chemical isomerism in cyclic molecules, this is cyclopropane 1,2 dioic acid, which is a cis isomer since the two COH groups are presented towards the same side, and this is trans cyclopropane trans 1,2 dioic acid. Coming to the chemical isomerism in oxides. Oxides are the condensation products which are obtained by the reaction of aldehydes and ketones with hydroxylamine. When an aldehyde or a ketone condenses with hydroxylamine, the resultant products are called oxides. Those oxides also exhibit geometrical isomerism. So the geometrical isomerism in oxides is named as syn and anti. And an isomer which is having the OH and H present towards the same side of a carbon-nitrogen double bond is called syn isomer, and an isomer in which the OH and H are present in the opposite direction of a carbon-nitrogen double bond are called anti-isomer. This is in case of aldehydes, whereas in case of ketones, please remember, so you have to name by yourself. Let me take one more example. This is CH3 and this is your C6H5. This is acetophenone oxide, and so that is acetophenone oxide. And remember, and let me take one more molecule, the same molecule in the opposite fashion. So now, in case of ketone oxides, The geometrical isomer is named as a syn and anti based on the naming of the priority. This is commonly methyl phenyl ketone. Methyl is named first, that is number 1. And this is methyl is named first, that is number 1. So the first named group and the OH group, if they are present towards the same side, then it is called as syn isomer. The first named group and the OH group, if they are in the opposite side, then it is called as anti-isomer. So this is how we are going to name the geometrical isomers as syn and anti-isomers in case of oxides which are obtained by the condensation of aldehydes and ketones with hydroxyl amine. I hope so it is clear regarding geometrical isomerism in case of carbon-carbon double bond containing compounds, in case of compounds containing a cyclic carbon skeleton, and in case of oxides. Okay, thank you.